thank you very much for joining me today. We're at the European Sustainable Energy Week, and you just finished your panel discussion on AI. Normally, we start discussing AI with the challenges. I would like to start the other way around and ask you about the benefits of AI.
Yeah, thank you very much. I think AI is very much now at that pivotal point where investments need to be made, and they need to get those machine learning algorithms to get very smart. And how do you do that? It's data. For decades, the energy sector, the ecosystem, has been producing so much data it can't utilize. If they can actually fully utilize that data, what will you have? You'll have grids that will be able to be flexible. If today, if everybody had an electric car or purchased one, right, the whole system would collapse. We would have blackouts everywhere. So you need a grid that's flexible. You need a grid that will be able to take on renewables, right? AI will also take the money that's being invested every day. There's literally tens of billions that are invested to make energy systems, more sustainable, more efficient, and also to consider about some new power sources that we keep hearing about to move this, the science fiction to be science, right? And then finally, what we see is a huge amount of sustainability that will happen. We will see energy up to 50% that will disappear because of efficiencies, of a lack of need even for that energy. AI will drive all these benefits.
For AI to drive all these benefits, like you said, we need data, like you also said, and data centers. And I've seen that the last years we have more and more data centers growing in a way in European soil. But do you think we're at the correct road with data centers?
Let's first look at I think what they call the elephant in the room, right? And that's the energy consumption of data centers. If you remember in 2008, they were actually saying data centers were going to consume and grow a carbon footprint over 4%. That was the fastest growing size of any type of industry. But that never happened. We are now 2024, and the CO2 emissions of a data center is still very stable at 1.8 to 2%. And why is that? Because there is so much innovation that is pumped into data centers. You cannot have a data center operator that is using or creating data centers that cost a lot of money. No CO2 would want that. So they have to be highly, highly optimized. So that's one thing. There is, as I said, tens of billions invested to make them very efficient, where they're using natural air economizers to make sure that you don't need electricity to chill and cool down the data centers. It's using closed circuit water economizers, sewage, to cool down those data centers. So the energy needs start dropping dramatically as the carbon footprint does. So that's the first thing. And then the second thing is the data center is not creating ethical issues, right? It's how we use data that creates that. And that is a very heavily regulated space. The European Commission has, over the past couple of years, created the GDPR. And this is not communicated very loudly. But if you go to Article 1.3 of the GDPR, one of the main purposes the GDPR was created was that personal data, sensitive data, as it says in that article, can flow freely and cannot be restricted by a member state, right? That was the first fundamental step that the European Commission did to make sure that it can have data flowing in the EU, which is now going to be the foundation of a future energy data space.
As we move a little bit towards the challenges of AI, I want to discuss safety. There's a lot of concern when it comes to AI and safety, from citizens, from politicians, but I would like to also insert data spaces, because there is also concern there in data spaces and how the data are being used. So my question is, Are our data safe? Is AI safe for us to use?
So that's a very good question. Let me unpack that first. Let's talk about safety. So we actually have very clear examples that AI has been used and has actually led for safety for many decades. If you look at the airline industry, commercial jets have been flying since the 60s and 70s, largely using AI. A commercial pilot today would struggle to fly a commercial jet as AI makes sure that that plane can take off, go through turbulence, storms, adjust by itself, and land safely. And all that functionality is largely due to AI. In the energy space, we have the nuclear systems. So if you look in my country of France, the nuclear power plants are largely run by AI. And we unfortunately have examples where you take the digital and AI out, such as in Fukushima, such as in Chernobyl, where accidents do happen. So AI takes that human error away and makes these systems a lot safer. So that's the first thing, to think about. When we create a data space, that fundamentally means that data can flow from one member state to another. If you want to dream a project where you are going to have solar-powered energy from Spain coming up to Belgium, you're going to need that data space. We do not understand fully, the benefits of energy, of data, of how to use that, how to have systems to interconnect, the safety requirements and interoperability needs, right, that will be needed for a scalable large project. We do not have one scalable large project in the EU. We can only have that with the data space.
We do have, however, an AI Act, which is a regulation that is unique as it is the first one.
Fundamentally, my Director General was part of an expert group that was defining the ethics on AI. And that group, which was made of many stakeholders across the board, were proposing that it should be a risk-based classification model, looking at where more regulation requirements are needed based on the increase of risk. That is in the AI Act. So parts of it are very good. Regulation is important because it builds confidence for the take-up of AI. But the problem is the implementation of that, because the definitions in that act are not very clear. There will be a lot of legal discussions to clarify, what exactly, does that act mean? What do these definitions mean? How do you define these things, based on risk? And also, how do you make sure the fragmentation that the AI Act could produce if every member state was putting their own requirements and their own flair and their own flavor of how that is implemented? You could literally have a company that is trying to comply in every single member state 27 times, right? Which would probably lead to hundreds of thousands of euros, which is a lot of money for a startup. So these things have to be carefully done for it to be implementable. And then secondly, we need to make sure that that scale is global. It needs to be a global dialogue. We have the Hiroshima principles, we have the G7 discussions. So this has to continue so that globally we're developing and upping our game in what AI can really deliver.
So if I understand this correctly, you say that this act, the AI Act, is a nice start, but we're nowhere near the finish, right?
I think it's more about how we implement it. And we got to implement it as a single market in mind, not as 27 member states. That's where the AI Act will fail. That's where it will remove the innovation and the benefits of that AI promise. But if it's implemented in a harmonized way across the EU and makes the obligations, where it's not high risk, right, to be a burden on the companies, well then, yes, I think we will see more of that AI promise.
Could you give me some real-life examples of how AI can help us and make our lives better, let's say?
Yeah, sure, I definitely can. I think if you're an energy producer If you look at Finland, for example, you need to make a 100 billion investment over the course of 3 decades. They've been using AI to plan that out. That is with a target in mind of having 99.99% reliability in their grid system. AI will deliver that. AI will make sure that buildings that produce 40% of greenhouse gas emissions globally will be connecting with the grid and making sure that a lot of the HVAC systems are automated, right? If you look in manufacturing, for example, which takes up a lot of energy consumption, as we saw in my panel, mostly 60% plus of industry is consuming energy. Well, they don't have to consume that energy on peak hours. Most manufacturing will be increasingly automated. We'll have robots doing everything, and the robots can work all night. So instead of running in peak hours, it'll be running late night to produce the same product with high efficiency and being very sensitive on the grid.
Ray, thank you very much for this interesting discussion.
Yeah, thank you very much. My pleasure.
And thank you all for watching us. If you liked what you saw, don't forget to become a member of the Enlit community.